Here is a frustrating scenario that plays out constantly on engineering teams. A QA engineer runs a thorough, well-designed load test. They find real problems, P95 response times 3 times above the SLA threshold, error rates climbing at realistic concurrent user counts, a clear bottleneck identified and documented. They write it all up in a report. The report gets shared in Slack and email to the team. It sits. A week passes. Nobody has picked up any of the findings. The sprint planning meeting happens and none of the issues make it onto the board. The next release ships with all the same performance problems. And then 3 weeks later there is a production incident that the load test had predicted exactly. I have seen this happen at companies of every size, and the root cause is almost never that the team did not care or did not have capacity. The root cause is almost always the report itself. A report that is hard to parse, that presents raw numbers without context, that uses vague language in its recommendations. The report will not drive action regardless of how important its findings are. In this final episode of the series, you are going to learn how to write a performance test report that engineers prioritize and that managers understand, because those are genuinely different things and a great report has to do both. Start every performance report with an executive summary, and write it specifically for someone who will not read anything else in the document. This is not the detailed findings section. This is not the metrics table. This is one paragraph, 4 to 6 sentences, that tells the whole story. State what you tested, the specific system or endpoint, the load level, the duration. State the result. Did the system pass, fail, or show degradation above a certain threshold? State the most important finding in plain language. State the recommended next action. Here is an example of what that looks like in practice. We load tested the checkout API at 200 concurrent users for 30 minutes against the staging environment. The system handled load acceptably up to approximately 150 concurrent users. Above that threshold, P95 response time exceeded 2 seconds, 4 times our target SLA of 500 milliseconds, and the error rate climbed to 4%. The primary bottleneck appears to be the payment service database connection pool, which is currently configured at a maximum of 10 connections. That is the entire executive summary. A manager can read it in 30 seconds and understand what happened, what the impact is, and what needs to happen next. The most common weakness in performance test reports is presenting metrics without context. Raw numbers alone are almost meaningless to anyone who was not present for the test. Do not just write that P95 response time was 1.2 seconds. Write that your SLA target is 500 milliseconds, so 1.2 seconds represents a 140% overage, and that based on your traffic model, this would affect approximately 8,000 users per hour during peak traffic periods. Do not just write that the error rate was 3.5%. Write that in production this would represent roughly 3,500 failed requests per hour at current traffic levels, each one a user who received an error instead of a successful response. Translating technical metrics into business terms, affected users, failed transactions, revenue risk, is the single most effective thing you can do to make your findings actionable. Engineers understand milliseconds. Managers and product owners understand users and money. A good report speaks both languages. Visualizations are not optional in a performance test report, they are essential. A data table with dozens of numbers requires significant effort from the reader to extract meaning. A well-designed chart communicates the same information in seconds. The single most useful chart you can include shows response time and error rate on the vertical axis plotted against time or virtual users on the horizontal axis. Your reader should be able to see, at a glance, exactly where the system starts degrading. Find the inflection point, the moment where the line bends sharply upward, and annotate it. Draw a horizontal line at your SLA threshold so the violation is visually obvious. K6 can export its results as JSON or CSV, which you can import into a spreadsheet, a Python plotting script, or Grafana. Grafana Cloud has a free tier with a K6 integration that produces dashboard visualizations automatically. Even a basic chart created in Excel or Google Sheets and pasted into your document is dramatically more effective than a table of numbers. The goal is to make the problem visible in 5 seconds, not after 5 minutes of reading. The findings section of your report is where most of the value lives, and each finding needs exactly 3 things to be actionable. First, a severity rating, critical, high, medium, or low, based on the user impact at realistic load levels. Be honest about this. If something breaks your application at 80% of your expected peak traffic, that is critical regardless of how complex the fix might be. Second, a clear description of what you observed and what it most likely means technically. Not vague language like performance is degraded, specific language like P95 response time increases from 180 milliseconds to 2.4 seconds when concurrent users exceed 150, consistent with connection pool exhaustion. Third, and most importantly, a specific recommended action. Not investigate the database. Increase the payment service PostgreSQL connection pool from 10 to 50, add connection pool monitoring to Datadog, and rerun this load test to verify the fix resolves the saturation. The more specific your recommendation, the easier it is to assign, estimate, and execute. Vague findings get added to a backlog. Specific, well-described findings with clear recommended actions get fixed. That is a wrap on Series 6, Performance and Load Testing for QA Engineers. We covered a lot of ground in this series. You learned what load testing is and exactly why teams skip it. You wrote your first K6 script and ran it against a real endpoint. You learned to read results properly using percentiles instead of averages and to spot saturation points. You compared K6 and Locust and built a framework for choosing between them. You learned the difference between stress testing, spike testing, and soak testing and when to use each one. You integrated load testing into a CI/CD pipeline with automatic pass/fail thresholds. And you learned how to communicate findings in a way that actually drives action. These are not beginner skills. Most QA engineers working today do not have them. If you have made it through this entire series, you now have a meaningful advantage. Share this series with another QA engineer who needs it. Subscribe for Series 7, where we are going to cover security testing for QA OWASP, common vulnerability classes, and how QA engineers can meaningfully contribute to a security testing program. Drop a comment letting me know what you thought of this series. I read all of them. See you in Series 7. I want to leave you with one final thought about the role of performance testing in a QA career and why investing in this skill matters beyond just the technical competence it gives you. Performance testing is one of the few areas of QA that sits at the intersection of user experience, engineering architecture, and business outcomes simultaneously. When you find a bottleneck that degrades user experience at realistic load levels, you are not just filing a bug, you are potentially changing an architectural decision, influencing an infrastructure investment, and preventing a revenue-impacting incident. That kind of cross-functional impact is what gets QA engineers invited into conversations they would not otherwise be included in. It is what builds the professional credibility that opens doors. The QA engineer who can say I ran a load test, found that we will start dropping requests at 80% of our projected peak traffic, traced it to a specific bottleneck in the payment service, and recommended a concrete fix that was validated with a follow-up test. That engineer is contributing at a level that is visible to the whole organization, not just the QA team. That is the opportunity that performance testing represents. Take it seriously, invest in the skill, and it will pay dividends throughout your career in ways that are hard to predict but consistently valuable. Thank you for spending this series with me. I will see you in Series 7.